What if the greatest engineering secrets are not found in modern labs, but are hidden in the wild, waiting to be rediscovered? This man is about to construct a series of structures that defy conventional methods. It all begins with the most critical phase of any build, the excavation and foundation. He isn't just digging a hole, he's analyzing the soil composition, a stable, red-brown clay, ideal for a subterranean base. One miscalculation in the load-bearing capacity of these walls, and the entire project could collapse. The precision here will determine everything that follows. The pressure is on. Using a high-angle attack, he efficiently removes material, maintaining the structural integrity of the pit. Every swing is calculated, shaping the earth to his exact specifications. Now, the first structural element is introduced. This timber acts as a primary support beam for the retaining wall. Material selection is key. He's sourcing timber for the shoring system that will hold back the earth. A hand drill. This allows for precise joinery, creating connections without modern fasteners. The assembly of the subterranean framework begins. This is a classic earth-sheltered construction technique. Each blow of the hammer compacts the joints, ensuring a tight, load-bearing fit. He meticulously adds to the wooden skeleton, a system designed to resist immense lateral earth pressure. The result is a remarkably stable underground chamber, built with stunning efficiency. A final inspection. The geometry is sound. The structure is robust. Stage 1 is a success. The close-up reveals the quality of the joinery. Tight seams are crucial for stability and insulation. With the foundation secure, the builder can look on, knowing the hardest part is over. This isn't just a pit with wood, it's a marvel of primitive engineering. The structure stands complete, a testament to the power of fundamental physics and natural materials. Every piece of timber plays a role in this complex, interlocking system. He gazes upon his finished work, a functional shelter, carved from the forest itself. Now, a new challenge begins. The next phase involves creating a roof structure for the subterranean bunker. He carefully lays the initial support logs, which will bear the weight of the roof and the earth above it. Positioning is critical. He ensures each log is perfectly seated to distribute the load evenly across the retaining walls. Notice the technique. He's not just cutting, he's shaping the ends to create a primitive but effective form of joinery. He enters the structure, preparing to install the internal framework for the roof. Here, he carves a notch, or mortise. This will receive another piece of wood, locking the frame together without a single nail. The framework is laid out. This simple truss design will provide incredible strength and support. He fashions a wooden peg, or tenon, and uses a stone as a mallet. This is a demonstration of pure, ancient carpentry. Cutting at an angle is essential for the roof's pitch, allowing it to shed water and debris effectively. More fine-tuning. Each piece must fit perfectly for the structure to be sound. The roof purlins are now being laid across the rafters, forming the substrate for the final roofing material. A moment of inspection. He assesses the alignment and stability before proceeding to the final stage. The interlocking grid of the roof frame is a beautiful example of geometric strength and intelligent design. He continues to build up the roof structure, a painstaking process that demands patience and skill. Final adjustments are made, ensuring every component is secure and perfectly aligned. The completed shelter, a subterranean fortress, perfectly integrated into its environment. He can stand beside his creation, a testament to what one person can achieve with knowledge, skill, and determination. The details show the mastery. The joints are tight, the lines are clean. It's a functional work of art. From the outside, it's almost invisible. A masterclass in camouflage and sustainable building. The project is complete, a robust, hidden sanctuary ready to withstand the elements. With one project finished, another begins, this time an above-ground frame structure. He begins by processing the raw material, cutting larger logs into usable construction timber. Using a knife, he crafts a joint. This level of detail ensures the frame will be strong and stable. The first wall of the frame is hoisted into place. The design is inherently stable and excellent for shedding rain. Now, the roof ridge beam is set. This is the central spine of the entire structure. The triangular roof trusses are being installed, a simple but incredibly strong geometric form. A brief interlude. Even as he builds the ecosystem, he is part of continues its own cycle of life. Back to the build, he begins laying the roofing slats. This requires careful overlapping to ensure it's waterproof. From inside, he can appreciate the shelter he's creating. The geometry provides a surprising amount of headroom. Using a mallet, he secures a critical joint. The integrity of the roof depends on these connections. More material preparation, each piece for the roof, must be cut to a precise length. He is creating the timber that will become the shingles or planks for the final roof covering. Now, he constructs a sawbuck, a custom piece of equipment, to make processing lumber safer and more efficient. This is a genius technique. Using wedges, he splits a large log into rough-hewn planks, a primitive milling method. With the planks split, he now cuts them to size, preparing them for installation on the roof. The planks are laid out on his custom-built workstation. This is a production line for roofing material. Each plank is measured and cut with care. Consistency is key to a well-built roof. He now begins the painstaking process of layering the wooden planks onto the roof frame. The overlapping pattern is crucial. It creates a barrier that channels water away from the interior. He cuts the final piece for the roof ridge cap, the component that will seal the very peak of the structure. The last piece is carefully fitted into place. This completes the primary weatherproofing of the shelter. A final inspection tour. He checks the seams, the stability, and the overall quality of his craftsmanship. The frame hut stands complete, a simple, elegant, and highly functional shelter built from scratch. With the structures on land complete, an ambitious new phase begins. The challenge, building across water. The following period involves intense, off-camera work. As he prepares the foundation for a complex bridge structure, the principles of civil engineering are universal. Here, he prepares the abutments that will support the bridge. Sourcing the right materials is more critical than ever. The bridge timbers must be strong and rot-resistant. The unseen labor is immense. Each piece of timber is felled, moved, and prepared by hand. Days of work are condensed into moments. The preparation of the primary beams is a monumental task. The site is prepared. The engineering calculations are all done in his head, based on years of experience. The basic laws of physics are his only guide. Tension, compression, and load paths are his primary concerns. The complex joinery for the bridge's support structure is carved with painstaking precision. Soon, the culmination of this intense preparation will be revealed as the bridge begins to take shape. The silence of the forest belies the complex, problem-solving and physical effort taking place. He must ensure every component is perfect before the assembly over the water begins. The first signs of the new structure emerge from the dense forest landscape. After hours of unseen labor, the bridge's support trusses are ready for assembly. This is a critical moment, the transition from land-based work to over-water construction. The genius of the design will soon become apparent, strength from simplicity. The construction is far from over. The most technically demanding phase is about to begin. The gap is bridged, but can it support a structure? The true test of his engineering skill is next. The forest provides the materials, but knowledge and skill are what turn them into a lasting structure. The final preparations are made before the main assembly. There is no room for error. The stage is set for one of the most ambitious, primitive construction projects imaginable. The first piece of the substructure is placed. He's compacting the earth to create a stable pier base. The small, dark space is the anchor point, the foundation upon which the entire bridge will rest. He secures a crossbeam, transferring the load across the earthen foundation he has prepared. In this cramped space, he lays out a blueprint. On paper, a rare use of modern tools in his workflow. He now moves to sourcing the main structural timbers, selecting a tree with the ideal strength and straightness. The felling and processing of the main beams is a physically demanding and dangerous task. He strips the bark to slow decay and prepare the timber for shaping. This is crucial for the bridge's longevity. The forest floor becomes his workshop, littered with the raw materials for his ambitious project. Again, we see the mastery of hand tools. He carves a precise joint that will lock the frame together. He traverses the site, carrying his tools in a simple pack, surveying the landscape for the next phase. He carefully shapes a peg that will act like a bolt, securing the main joints of the bridge's trusses. He applies a waterproofing agent, likely a natural resin or oil. This is a critical step to protect the wood from the creak. The triangular support truss is assembled on land first. This is the heart of the bridge's strength. He adds more members to the truss, increasing its rigidity and ability to carry a significant load. With the truss complete, he carefully moves it into position over the stream. The bridge now stands, a testament to his skill, a simple span bridge, perfectly executed. He tests its strength, walking across carefully. The structure is solid. Now he adds the decking and handrails, transforming it from a structural skeleton into a finished bridge. Final details are carved and fitted, showing a commitment to both function and form. The completed bridge, a triumph of engineering, providing safe passage and a platform for his next, even bolder project. But the bridge was just the beginning. Now he will build a structure asterisk on asterisk the bridge, over the water itself. He lifts a massive beam into place. This will form the base of a temporary workshop for processing lumber. He custom builds a sawhorse on site, a testament to his adaptability and foresight. Back in the forest, he selects and fells more timber, this time for the walls and roof of the waterborne shelter. The search for the perfect raw material is a skill in itself. He needs straight, strong wood for this precision build. The processing is relentless. Each log is sawn to length by hand, a task requiring immense stamina. With a knife, he shaves and shapes the timber, preparing it for the next stage of milling. Using a broad axe, or adze, he begins to hew the log, flattening one side to create a stable plank. This is a powerful and dangerous technique, requiring precision and control with every swing. He uses a framing square to ensure his cuts will be perfectly at 90 degrees, a blend of ancient technique and modern precision. A pencil line marks the cut. From this point on, the work transitions from rough construction to fine carpentry. The saw follows the line with incredible accuracy, creating a perfectly square shoulder for a joint. The waste material is cleanly removed, revealing the precisely cut timber. Using his custom-built workstation, he can now ripsaw planks with remarkable consistency. Now, an unexpected tool, a hand plane. He begins to smooth the rough-sawn planks into finished boards. Each pass of the plane shaves off a paper-thin layer of wood, revealing a smooth, flat surface. This is no longer just survival building. This is high-level craftsmanship in the wild. The pile of finished lumber grows, each board a testament to his skill and dedication. The quality of these hand-planed boards is astonishing, rivaling what could be done in a modern workshop. With his materials prepared, the final, most impressive construction project can now begin. Back at his over-water workshop, he continues to plane the final boards for the floating house. He inspects his work, checking for flatness and smoothness. Quality control is paramount. The first floorboard of the house is laid on the bridge. This platform must be perfectly level and secure. Using a chisel, he carves out a mortise for a joint. This detail work is what separates a shack from a true structure. He lays more decking, methodically creating the floor of the small house. Each board is measured and cut to fit perfectly, a process that requires immense concentration. He ferries more of his hand-milled lumber across the bridge to the construction site. The final floorboard is tapped into place. The foundation is now complete. The triangular frame of the house begins to rise. The frame design is light, strong, and weather-resistant. He hoists the main ridge beam into place, the backbone of the new structure. The wall panels, made from his plain boards, are installed with speed and efficiency. He adds structural supports underneath the bridge deck, reinforcing it to handle the new load. The house takes shape, a tiny, perfect cabin, suspended magically above the flowing water. With a small axe, he shapes the rafters for the roof, each one cut to fit with precision. The roofing planks are layered on, completing the waterproof envelope of the house. He uses small wooden pegs, hammered into pre-drilled holes, to fasten the final roof boards. The completed house and bridge, a harmonious blend, of engineering, architecture, and nature. Final trim and details are added, showcasing a level of finish that is truly remarkable. He inspects his masterpiece. Every joint is tight, every angle is true. The final shot reveals an idyllic scene, a perfect tiny home, built by hand. Floating peacefully another in the harshest project begins. A floating house, built directly on a raft. He secures the wall panels of the triangular structure. Stability and weight distribution are the main challenges. He prepares a massive log. This will act as a primary pontoon, providing the buoyancy for the entire structure. Using a chisel, he carves a deep mortise. This will be a key connection point for the raft's frame. He hews the log, creating a flat top surface for the house's floor to rest on. On his sawbuck, he shapes another crucial component of the raft's interlocking frame. In a fascinating turn, he harvests natural clay from the riverbank. What could this be for? He mixes the clay with water, creating a primitive mortar or sealant. This is a brilliant use of composite materials. The house, now floating, looks stunning. The clay will likely be used to seal gaps and make it weatherproof. He continues to build the roof, each piece of timber, adding to the structural integrity. An overhang is constructed. This architectural feature will protect the walls from rain and provide shade. The interior work begins, fitting out the small space to be a functional shelter. A custom-built door is installed, fitting snugly into the frame he constructed. The floating home is complete, a testament to his incredible range of skills. From logging to fine carpentry, roof ridge is installed, capping off the beautiful and functional structure. He performs a final, thorough inspection, ensuring his floating sanctuary is perfectly sound. Even a small window frame is crafted and fitted, a detail that turns the shelter into a true home. He stands back to admire his work, a complete, self-sufficient floating home built from nature. The final step is to clean the worksite, leaving the surrounding nature as undisturbed as possible. The story concludes. A master craftsman has once again tamed the wilderness with skill. The final project showcases the pinnacle of his craft. Here, he adjusts the fit of a perfectly constructed door. The house features a tight, triangular design with a window, a marvel of wilderness architecture. The material processing is still done by hand, shaping a log on a simple, site-built sawhorse. He uses a wooden mallet to drive a wooden peg, a timeless joinery technique that creates an incredibly strong balcony, complete with a handrail, adding both safety and aesthetic appeal. The house sits serenely beside a gentle stream, a perfect integration of a man-made structure into the landscape. In the final moments, he works near the water's edge, completing the foundation and access to his streamside hut. A very special thank you to the owner of the YouTube channel Bushcraft Ideas for creating this wonderful video and allowing me to comment. If you enjoyed this narrative, please visit and support their channel at the link in the description below.